Alright, so today I am going to walk you through some right triangle trig applications and just a review of what you learned in geometry. And we're going to do a little bit with the unit circle, what we did on Friday. So let's first off let's just review some right triangle trig. And if we look at our triangle that we have here, we have sides A, B, and C. Take about 30 seconds with your partner and fill out what sine, cosine, tangent, cosecant, secant, and cotangent are. And here's what I mean by that. I want the ratio. So sine of theta would be opposite over hypotenuse, or B over C. So that's what I would like for all of the rest of these. So take about 30 seconds and do that. Alright, so let's check these. We have sine theta is B over C, cosine theta is A over C, tangent theta is B over A. And then we know for the rest of our trig functions, all we do is flip the fraction. So cosecant is C over B, secant is C over A, cotangent is A over B. Okay? Alright, so let's do some more problem solving with this. It says, find all of the trig values for sine theta equals 5 over 7. So we are going to find cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Okay, we already know what cosecant theta is because it's the flip of sine. So cosecant is going to be 7 over 5. All right, now add on your triangle, add you a theta up at the top like my triangle is drawn. So we need to put our ratio on our triangle. So we know that the 5, if it's sine, it's opposite over hypotenuse. So the sine 5 over 7. So we need to find the other side of our triangle using Pythagorean theorem. Okay, so I'm going to come over here to the side. We have, I'm just going to call this one x. X squared plus 5 squared equals 7 squared. So that's x squared plus 25 equals 49. So x squared equals 24. So x is going to be 2 square root 6. So on my triangle up here, I'm going to erase my x. And I'm going to write 2 square root 6. Now I can answer the rest of my functions. So cosine is going to be adjacent over hypotenuse. So that's 2 root 6 over 7. Tangent is going to be 5 over 2 root 6, which I'm going to have to fix, but here's what I'm going to do with that one. I'm going to go ahead and come down here to the cotangent and flip it over, because I don't have to fix that one. Okay. The cosine, I'm going to flip to make the secant, but I'm going to have to fix that one too. So 7 over 2 root 6. I'm going to have to multiply by root 6 over root 6. Which gives me 7 root 6 over 12. And then do the same thing up here for your tangent. So square root 6 over square root 6. So 5 square root 6 over 12. Okay, I'm going to highlight these answers really quickly. So we have our sine is 5 over 7. Our cosecant is 7 over 5. Our cosine is 2 root 6 over 7. Our secant is 7 root 6 over 12 once we simplified it, or once we rationalized the denominator. Our tangent is 5 square root 6 over 12, and our cotangent is 2 square root 6 over 5. Okay? All right. Now let's look at finding a side when we know the angle. So I'm going to do A with you just to kind of remind you, and then you're going to do B. All right, so let's look at our triangle here. Here's what I always do to figure out which trig function. I always place myself at the angle and I look at what I have. So if I look at what I have here, I have, in comparison to my angle, the opposite and the hypotenuse. Okay, so I need to use sine. Sine 34 equals 5 over x. Put the sine 34 over 1 and cross multiply. So x sine 34 equals 5. Divide by sine 34. Divide by sine 34. So x is going to equal, go to your calculator, make sure that you're in degree mode because now we're talking about angles. And punch that in. So I got 8.94 inches. All right, so I don't know if you noticed, but my B is different than your B. So if you will try your B on your paper, and then we'll check that, and then we'll talk about this B. So try with your partner to work your B on your paper, and then we'll try this B. All right, so for my B, for the B on your paper, let me draw it real quick. We had a triangle that looks something like this. No, wrong angle. Something like that, where the right angle is here, 71 here, 12 here, y here. Okay, so we should be using tangent 71 equals y over 12. Put the tangent 71 over 1 and cross multiply. So y is 12 tangent 71, which I got 34.85 centimeters. Okay, all right. Excuse me. Let's look at this B on here real quick before we go on to the next thing. Okay, so the B that's on here is asking for you to find the angle. Okay, so if we write our trig function, it's going to look, when I put myself at my angle right here, I've got the opposite and I've got the hypotenuse. So we're back at sine again, but I have sine x equals 8 over 12. So then the question becomes, what do I do to get the sine off of the x? Because I can't divide by sine, and that's what that little button is above your sine on your calculator. So I hope that you see that. And we're doing sine inverse. So on your calculator, you're going to push second sine. So you have sine -1 is 8 divided by 12. Close it. Make sure that whole thing is in parentheses. So we have 41.81 degrees. Okay. All right, I hope that you remember these from geometry because I went through them a little fast. What I'd like for you to do is on that last little part on your notes page, I want you to write the 30, 60, 90 and the 45, 45, 90 ratios that we learned, that we reviewed. So our angle down here is going to be the 30, or the 30 and the 60. And then we're going to have the 45 and the 45. All right, so take a minute and write those ratios down. All right, so for 30, 60, 90, across from the 30, we should have a 1. Across from the 60 is square root 3 on the hypotenuse of 2. Across from the 245s are 1, 1, and square root of 2. Okay, now I want you to remember from yesterday, because we talked about radians yesterday and going from radians to degrees and on the unit circle. I want you to remember that 45 is pi over 4. 60 is pi over 3. Remember, it's the opposite of what you think. And the 30 is pi over 6. Okay? So with your partner, I would like for you to try example 3 on your paper and answer those 8 questions about sine, cosine, and tangent. And if you can do it without looking at the triangles, that's awesome. But if you need to look at the triangles, you can.
Hey, can I send the kid?
All right, about 30 more seconds to answer these 8 questions. All right, if 2 table partners will turn to 2 table partners behind you and check through these, I'm going to start writing them up there. Check with each other, and then we'll go through all these. All right, so run through a quick check of yours. Check yours with mine. All right, let's try going backwards now. So the question you have to ask, whoops, too far. The question you have to ask yourself is, what angle will give a function, so sine, cosine, tangent, cotangent, cosecant, secant, a given value. Okay, so a lot of times you will see these defined as being from 0 to 2 pi, not including the 2 pi. We're not going to keep going because there are infinite answers to this question. We can keep going around the circle. Or you may see it defined as from 0 to 360, not including the 360. So the question is, what would theta be if sine theta was 1/2? So if you look back at you can either look at your 30, 60, 90 or think about your unit circle from yesterday, and sine is opposite over hypotenuse. So opposite over hypotenuse of 1/2 is 30 degrees, or pi over 6 if we're talking about in radians. Okay, and now think about the theta on the bottom one. What theta would give a tangent of square root 3 over 3, which means that the original theta was this, or the original tangent was 1 over square root 3, because we don't have anything on our unit circle that's square root 3 over 3. So the original theta was 1 over square root 3. All right, so that ends up being the same angle as the one we just talked about, 30 degrees or pi over 6. Okay, grab your calculator. We're going to round these to 4 decimal places. The first 4, your calculator needs to be in degree mode. So you're going to have to flip modes once you get to number 5. Otherwise, you're going to get answers that are not the same as everyone else's, okay? So I want you to try 1 through 7. 1 through 7, make sure you're in degree mode for the first 4 and radian mode for the last 3. And then we will check in just a minute. All right, look up and check your 3 degree ones, and then we'll switch over. And if you've checked those, go ahead and flip your calculator to radians mode and do the last 3. Oops, writing in highlighter. Try that again. All right, check yourself real quick for these 3, and then we'll move on to our last 2 examples. All right, so solve the triangle. When you see these words, solve the triangle, that means you're going to find all missing sides and angles. Okay, so if we look at, sometimes I like to come over and make a list. So I need to know what little c is, or the hypotenuse. I need to know what angle A is and angle B. Okay, so little c is our easiest thing to find first with Pythagorean theorem. So 7 squared plus 4 squared equals c squared. So we have 49 plus 16 equals c squared. So 65 is c squared. So c is the square root of 65. You can add that into your list, square root of 65. All right, angle A. So here's what I don't like to do. Sometimes we like to say, we like to use one trig function over another. And what I mean is we like to do everything in terms of sine or cosine or tangent. But in scenarios like this, I really want you to go back to what's given, because if you use the square root 65 and say it was wrong, then you would be doubly wrong for answering A and B. So if we look at angle A, we're going to use tangent because we have our opposite and our adjacent. So we're going to actually use tangent to find A. So tangent A is equal to 7 over 4. Then I've got to use the tan inverse of both sides to figure out what A is. Okay, we're going to round to 2 decimal places. Make sure that you're in the right mode. If you get weird answers, it's probably because you're not in the right mode, which is what I just did. Okay, and so I got angle A is 60.26. If you got 1.05 yada yada, you're still in radians, and we need to be in degrees when we're in a triangle. Okay, now I know that since we know that this angle is 60.26, that I could just subtract 90 and 60.26 from 180 and get B. But again, it's that whole principle of what if I messed up? What if I messed up A somehow and then I use it again to find B? Then I've got 2 wrong answers. So we're going to go back to our triangle and we're going to use tangent again, but now tangent of B is 4 over 7. So then when I find the tan inverse of both sides, I get B is equal to 29.74. So 29.74 degrees. Okay. All right, the last problem we're going to try is an angle of elevation or depression problem. And so don't make fun of my drawing when I draw our picture for this one. So we are going to calculate the angle of elevation of the line of sight of a person whose eye is 1.7 meters above the ground. So I'm going to draw our person. Okay, their eye is 1.7 meters above the ground. Okay, is looking at the top of a tree. So let me draw a tree here. I'll even add some color to it. There you go, there's our tree. Our person is looking at the top of this tree. Okay, the top of the tree. They are 27.5 meters away from the tree. And the tree is 18.6 meters high. Okay. So I want to know what's the angle of elevation that they're having. How far are they having to tilt their head to see the top of that tree? So I need to drop a line right here and make this into a right triangle. Let me do that a little bit different color. all of my trees getting in the way. Darken that in. Okay, now here's what we have to do. Because we know the tree is 18.6 meters tall and the person is 1.7 meters above that, we actually have to subtract the 18.6 minus 1.7. Okay, so 18.6 minus 1.7 gives me 16.9 meters. Okay, that's actual tree height to the top. So then it becomes an easy problem. Now I just stand at my angle and know I have the opposite. I have the adjacent. That is tangent. So tangent theta equals the opposite, which is 16.9, divided by the adjacent, which is 27.5. Okay, and we should know now, because we've done it several times, how to get the tangent off of the theta. I take tangent inverse of both sides. So theta is equal to 31.57 degrees. Okay, so there's one application problem. So angle of depression problems are just going to be turned upside down. So let me draw you a quick example, then I'll set you loose. So say you have somebody who's standing on, like at the Grand Canyon, and they're looking down here at a river. Okay, so the angle of depression problems would be drawn from like this down to whatever spot the person wants to look at down. So be sure you pay attention whether you're drawing angle of elevation or angle of depression. Depression would be turn your head down towards something. Elevation would be turn your head up towards something. Okay? All right. So good luck with the homework. Let me know if you have questions. You can send me an email and I can hopefully shoot some answers back to you. And I will see you on Wednesday.